All right, everybody. These are some notes to help you with your STAR project. We thought these might help some of you with some of your information. So I'm going to zoom in here because this is very far away for you to see. So I'm going to zoom in and I'm going to use my spotlight to spotlight what I'm talking about. So let me zoom in here, make this easier for us. All right, some stuff we've been talking about. So nuclear fusion, remember nuclear fusion is the combining of two nuclei or atoms to create the elements number 4 through 26. So all the way up to iron. And this is actually the birth of a star that we're talking about with nuclear fusion. So I'm going to go through some terms here that might help you that you're going to see in your project and hopefully give you some clarification. So the first one that you're going to see in your project is nebula. So what a nebula is a cloud of dust and gas. All right, so in space, and this dust provides a surface for hydrogen to cling to. So you got all this dust and gas in space, and then the hydrogen starting to stick to that dust, all right, as it's spinning around, okay? So we have a nebula. So that would be the beginning of a star, would be inside a nebula. Next, what happens is called a protostar. So we have proto in this picture of star here on our notes from last year. So what a protostar is, are clumps of hydrogen begin to fuse. So those hydrogens start to fuse together, all right? So they're starting to stick together. So during the fusion reaction, energy is being released. We saw that in our activity with marshmallows and the noodles. Energy is released. The temperature actually increases. Okay, so temperature is increasing within these protostars, and the star begins to glow. And also the star contracts. What contracts means to come together, all right, pushing in, all right? So the star starts to contract in, and this all happens during the protostar phase. Our next phase in a star's life is called main sequence. This is where a star becomes stable. Our sun is in main sequence right now. Our sun is stable. So this is pretty much like the teenage years of the star, young adults, where they're stable. All right, nothing's happening. Everything's good within that star. So this is called main sequence. And this is where we're getting hydrogens and we're starting to create helium within the star during main sequence. And what we mean by stable is, we have a picture here for you guys. The gas pressure is pushing out. So the gas within the star is pushing out equally to the gravity pushing in on the star. So what we get is called equilibrium. All right, so our gas pressure pushing out and a gravity pushing in is equal. So the star is neither expanding or contracting. It's just staying the same. So this is happening during main sequence. So what happens if a star starts to run out of hydrogen? If a star runs out of hydrogen, the pressure balance is off and the star will die. And we'll talk more about that. I'll show you some pictures here on other sheets of paper we have taken pictures of for you. So the star will start to die once the hydrogen starts to run out because nothing else can be formed. So that gas pressure starts to go down and stuff happens to the star. So let me go to our next slide. So I actually have these in a different order. So what happens when gas pressure starts to change? So if gas pressure is greater, all right, so there's more gas pressure within the star is going to start to expand, all right? So here you can see a picture. That gas pressure is going to push out. There's more gas pressure pushing out than gravity pushing in. So the star starts to expand, get larger, all right? What happens if gravity is greater? There's less gas pressure. So if there's less gas pressure and gravity is greater, the star starts to collapse. So it starts pushing in and the star starts getting smaller and smaller and collapsing on itself. So let's see what's happening here. So we run out of hydrogen. Helium fuel is then used to create carbon. All right, so we no longer have the hydrogen making the helium. Now those heliums are coming together to form carbon. Okay, and we've done this before in our marshmallow lab. 3 heliums make 1 carbon. All right, and that's where for carbon is 6 protons and 6 neutrons. Carbon has a mass of 12. Okay. So you're going to see a pattern here where those elements are getting larger and larger within the star as the star is dying. Okay, to use up the rest of the helium, we would have a carbon join with a helium, all right, leftover helium, and then we would get oxygen. Again, a larger element, 8 protons, 8 neutrons, a mass of 16. So you can see a pattern here. We're getting larger and larger elements. Once we get to iron, iron is the largest element we can create within the star. Energy must be put into the system from the outside. And what happens, this is where you get those explosions depending on the type of a star, the mass of a star. So, and we're going to show you that next slide. So once a main sequence star cannot make elements above iron 26, that's where it either turns into a dwarf, becomes a supernova, depends on the mass of the star. So I'll show that to you in the next slide. All right. Here we go. Let's go up. Again, I told you these were out of order. All right, so the star death. All right, so it's going to kind of go in order, and then it breaks off with the different types of stars, the mass of the stars. So again, all stars, we started with the Big Bang. We had a bunch of hydrogen atoms floating out there in space. And what happened to those hydrogen atoms? We talked about this earlier. We had nucleosynthesis, the creation of a nucleus. So we got hydrogen, we got isotopes of hydrogen, protium, deuterium, tritium. From those, clumps of hydrogen started to form. All right, and this forms within our nebula. Okay, so that was our cloud of dust and gas in space. So those clumps of hydrogen started to form. And again, that is called a nebula. From the nebula, we started having nuclear fusion. Those hydrogens starting to fuse together to form helium. And this is where our protostar starts to form, our baby star, if you want to call it. And the star starts to glow. Okay, so this is our nuclear fusion. And also in a nebula, there's many stars start to form within a nebula, not just one protostar, just to give you a heads up on that. From a protostar, our helium and hydrogen start to form carbon, and then we get carbon and helium forming oxygen, and all the way through iron. This is all going to occur during main sequence. All right, so the star is stable. Everything is good. All right, once we start running out of hydrogen, that's where the stars will start to die. All right, so here's a different path we can go. If you are a medium star, you're going to burn out and die after main sequence. If you are a massive star, you're going to start to expand. All right, what we'll call is a red supergiant. So different paths. A medium star will also become a red giant, but a massive star will become a red supergiant. And from that path, a massive star will become a supernova. And this is how we get our 86 elements after iron. So this is a large explosion. So after a red supergiant phase, a massive star will explode in a supernova. And from a supernova, it could turn into a neutron star or a black hole, depending on its size. And I'm just going to go back over here to a medium star, low mass star. So medium stars, mass stars, and low mass stars, they do burn out and die, but they do take different paths. We don't have it on here. Some will turn into black dwarfs, white dwarfs, also something called a brown dwarf, which you'll see in your projects if you're doing those stars. So that's something you would also have to look up. So hopefully this helped you out with your understanding of the different types of stars. It's hard doing this virtually, I do understand, but if you have questions, please ask us in our breakout rooms today. So thank you, and I am out of here.